Hello everyone, greeting from me again. We are still in the system control class in the topic of intelligent control, which is fuzzy logic. The previous class we have ended up with falsificate topic. Falsificate topic is a grouping of input. We're talking about what is grouping, what membership function looks like, such as linear membership function, or it can be other function. It depends on us. But if output going to be good or not, we have to try doing experiment. We cannot tell that this kind of system would be suited for this membership function. But most of system usually work with a linear membership function because we always want system to be linearity. But if we try doing experiment and it's not work, we may be changed to another one. Okay, let's do some review. This is the structure of fuzzy logic. When input first coming in, it has to be falsificate, which is a grouping that we have learned in the previous class. So today we're gonna learn in the topic of inference, which work along with rule base. It is a mapping process which will tell us that this kind of input should be proper with this kind of rule. And then it will go to defuzzificate process, which will calculate for output. The rule base is a rule which set from human logic. And human logic basically is a rule of if and then. If and then. Okay, so this class I will pick up some example of system control with fuzzy logic, where fuzzy logic will be used instead of PID control. Okay, let's have a look. Ah, this is the example. It is inverted pendulum. Inverted pendulum. So what is inverted pendulum? It is some kind of a vehicle. When the beam on the middle fall on the right or on the left hand side, okay, suppose that it fall on the right hand side. The vehicle will also move to the right hand side because this inverted pendulum system will try to maintain the balance of this beam to be in the middle. So our set point or set point of system, if you compare to PD control, the set point will be at 0 all the time. Okay, if the beam fall on this side, we will define theta as negative value. Again, fall on the right hand side, theta will be negative, and fall on the left hand side, theta will be positive. If vehicle move to the right hand side, the velocity will be positive and will be negative moving on the left hand side. Okay. Then, how this knowledge of inverted pendulum will be used? If you know a balance board, you will imagine how it works. Okay, I will show a video. It's exactly how we use this balance board. If we incline, it will move forward or backward. Left and right incline is used for turning left and right. We use this knowledge to create this balance board. See, if we if more we incline, the faster it will be. Okay, I hope it's more clear now. Okay, let's make some review. This is our fuzzy set. Two sets from above are fuzzy set of input, and the other one is a fuzzy set of output. And this is rule-based. So how these things work together relatively, I will describe for you. Don't be worried. Like I have said, fuzzy set, a fuzzy set will have some ambiguity. It won't say, okay, this would be 0, or negative small, or negative large. It has some range. In the range of 0, it may take uh, it may take from minus pi quarter to pi quarter. This range can be changed, depend on creator or developer. It can be made from more triangle. The first triangle is a set of, I would say, it a 0 group, or written as 0 to be easy to write on the rule-based table. The first set, which is 0 set, will derive input from system in the range of minus pi quarter to pi quarter. It means that error is theta feeding in. Again, so error is theta, which feed in, and it is the angle which the beam move away from set point. It's like PID, that the set point is unit step function, like here. 0 is the set point, but this set point always be at 0 all the time. And the error is this angle, which the beam move away from. Okay, if error is between minus pi quarter to pi quarter, it will be in 0 set. If you see membership at this point, it has membership at 1. Seems like it has probability of that set, and that it is a membership value. The highest value is 1, but if it's around here at 0 or minus pi quarter, it would not be in the 0 set because it's just on the boundary of the set. But if it's over than minus quarter, the membership value will be increased according to linear function. If it's a curve, the value will increase according to the curve function, depend on what we choose. If it's at 0, it means error is also 0. Its membership value at 100%. It is clearer now. Do you understand how fuzzy set is vague? I mean, it won't determine the value whether it's high or low. At the same time, the value that a bit higher than minus pi quarter is also in the set of negative small. Here, over here. There are many different membership value. If it's around here, around here, the membership value of 0 set is lower than membership value of negative small. And then it will go to this defuzzification process for the output. This is how vague of fuzzy logic. Okay, next, the second input, which is derivative of error. That's its derivative angle by time. It is omega, or angular velocity. It is a velocity of the beam that moves away from the set point. It also uses the same range of the first input. If we set it relatively, it will be easy to calculate. The last one, output. See, it is set relatively to each other. If it's moved to the right, it will be positive large. and move slowly will be positive small, or if it has no motion, it would be 0. In this example, the unit that we are given is Newton, which is the force that used to move this vehicle. But in a real usage, like I have said about balance board, it's usually used DC motor and controlled by power with modulation signal. So it can be used this mathematics to calculate power with modulation as the percent of duty cycle of power with modulation to tell that what percent of power with modulation would be. Positive large maybe for about 100%. Positive small is maybe around 50%, and negative small maybe also 50%, but in the opposite way. And for 0, it maybe it stop moving. Okay, this is how we do falsification again. This is how we do a falsification here. When we have done falsification of input and output already, then do mapping in inference and rule-based process. Next, the way we set the rule of fuzzy or rule-based mainly has two methods. Okay, let me see here. There are Memdani model. It's read Memdani model, and TSK model is some kind of Japanese language, I think, and SAM. The most famous method is Memdani method because it set the rule by use if the logic and don't have any equation. It's only use human logic, but for TSK, the output of it also use if and then logic, but finally the calculation of output must use some kind of equation. Okay, let's see. Fuzzy rule of Memdani. It would have if, yeah, if x1, which the value that system receive, basically is an input. If compared to the previous example, it is a theta. Theta is A11, which is in negative small or positive small or some particular group. When there are two input, so there are two event, then we connect it by and logic, like human logic. If it's rain and I dry clothes in the sun, then my clothes are wet, something like this. This is the imitation of human logic. Okay, if theta, which is some particular group, which in some particular group, and is important connected by and logic. Okay, and omega velocity is also in some particular group, then followed by output. Because there are two inputs, so there are two events. Then output. So how is output going to be? I will describe for more detail with example later. This is the rule base. Okay, next, let's see the another method, TSK model. See, there are a lot of mathematical things. Okay, let's pass this section because if I go in the detail, this can separate to the another subject. Wait, here the name TSK is from Takaji Tsujino Kan. It's also used if-then logic, but when we calculate for output, see here, y is a function of x1, x2, x3 equal to equation with coefficient, and this equation is the thing that we have to find it. the way to create this rule is very complicated, but it still has some advantage. It's more accurate than Mamdani method. But if we cannot find the equation, then use Mamdani method instead. Let's get back to example. We already know how to set the rule by Mamdani method. Use if-then logic with even to calculate the output. Get back to our example. See, here the rule base. There are two events. The first event is error or theta, which is in negative small negative large or positive small positive large. And change in error is error dot or derivative of error, which is an omega velocity in the unit of radian per second. If error has negative value in negative large group, and here at -2 group, if error has a high value, which means a large angle, and it's in a negative large group in this set, then do AND logic with error dot. And error dot is also in a negative large group. Again, it's also in the negative large group. It means that the beam falls very fast. So if the angle is large and it falls very fast, according to our sense, where the vehicle should be moved, according to my logic, I think it should be moved to the right side with a high velocity, which is a positive large. See, we have set the rule according to our thought. We have set the rule according to our thought. Suppose that error still in negative large or -2. Again, if it's still in negative large, but change in error is 0, or the falling velocity is 0. Because error still in negative large, it means that the angle is large. So the output of vehicle should balance it by pull the beam back by move to the right side very fast. This is the logic of example here. But someone may say it should not move that fast because it may exaggerate. It may be set at 1. It's no wrong, but we have to see at the result of experiment. Okay. If we define error at 0, the beam would be here, at here. If error is 0, but change in error is 2 or positive large, it means that the velocity is in the right direction rapidly. Again, the angle is at 0, but the velocity moves to the right side very fast. So the vehicle should move to the left, very high velocity. Okay, the vehicle should move to the left, very high, with very high velocity or -2. But it may be -1, depend on each individual logic. We have to do experiment. But one secret about setting the rule is trying to make it symmetry. This is enough for today. See you next time. Bye.